we're going to build the series for the function 1 over 1 minus x. And so always, we use this expansion formula for a Taylor series. And so in order to do this correctly, I'm going to need a bunch of derivatives. The first derivative, the second derivative at 0, third will probably be enough. Hopefully that'll help me understand what the nth derivative pattern is going to become. And so we'll start with just the very simplest, hey, what is f of 0? Well, when I plug 0 in, 1 over 1 minus 0 is 1. So my first term is going to be 1. And now I'm going to need to compute some derivatives. And I've done so here, rewriting 1 over 1 minus x as 1 minus x to the power of negative 1 gives us negative 1. I subtract 1 and get a new power of negative 2. And this negative 1 comes from the chain rule, the derivative of the inner. Rewriting this, I have 1 over 1 minus x squared. And when I plug 0 in, I get 1. So this first derivative is going to be 1. Now I'm going to take the derivative again. So I'm really taking the derivative of 1 times 1 minus x to the negative 2 power. Well, this negative 2 comes down. Subtract 1 for negative 3, and I have to multiply by the negative 1, which is the derivative of the inner, and I get this, which simplifies to what you see in yellow. And when I plug in 0, I get 2. So my second derivative at 0 will be 2. I'm going to do it one more time. Rewriting, I have 2 times 1 minus x to the negative 3. Multiply forward. A negative 6, but I also have a negative 1 from the derivative of the inner, and when I subtract 1 from negative 3, I get negative 4. Rewriting, I have this. Plugging in 0, I get a positive 6. So the next derivative would be a 6. And so now I'll write down everything that we have. 1 plus 1 times x over 1 factorial plus 2 times x squared over 2 factorial. 2 factorial is just 2. Plus the third term would be 6 times x cubed over 3 factorial. Well, it turns out that 3 factorial is just 3 times 2 times 1, or 6. So those make 1. 2 factorial is 2. That makes 1. That's 1. And so as I continue, I have 1 plus x squared plus x cubed. Hopefully you see the pattern. I'm also going to have x to the 4th, dot, 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 summation n equals 0 to infinity of x to the n. Now let's just double check to make sure this is the right nth term. When n is 0, x to the 0 is 1, and I have my first term. When n is 1, x to the 1 is my second term. So I know I have this right. I've built out the infinite series for 1 over 1 minus x, and it is this in green.